Without taking more of your time, I would like to invite to the stage our first speaker, my former colleague at AWS, creator of Lean, Leo de Moura.
It's an honor to be here. I didn't really know what to talk about. I asked Sebastian and him for help, and they suggested, and we want to keep you all engaged. And Sebastian suggested, let's talk about Lean's history. I never heard you talking about it. And okay, the talk is dedicated to Sebastian. Before Lean, there was Z3. Z3 is a fully automated theorem improver. You can view it as a constraint solver. You give constraints and it will return an assignment that makes the constraints true. For example, in this example, we're saying A should be greater than 3. The assignment is A equals 4. This kind of solver can attack problems in this complexity ladder. That's on the bottom, you have polynomial time problems, you have NP complete, and goes up to undecidable, right? And many people say the logic is the calculus of computer science, and that was the spirit for this kind of solver. For bug finding, especially for tools like Sage, we are really on the bottom of the ladder, right? We are solving NP complete problems. Basically, they're converting execution trace that leads to a security vulnerability into a set of constraints. And by solving these constraints, you find out the inputs that allows you to execute the program and trigger the security vulnerability. Sage is a tool built by Patricio de Fra. They found billions of problems. They created billions of queries for Z3 and found thousands of problems. And Patrice has amazing data showing that they track at Microsoft the number of bugs over time and dramatic decrease on the number of bugs in Microsoft products. So for bug finding, Z3 was very successful. And the success was not just at Microsoft. There are many research groups use Z3. The Z3 paper has more than 12,000 citations. It ships in product, even proof assistance. Isabel ships with Z3. It ships with Visual Studio, Slam, the static driver verifier. Yeah, but there are failures also. One failure is in software verification, right? People also use Z3 for verifying programs. What does it mean here? You put annotations in your programs. You're going to annotate your program with invariants, assertions, and so on. And in this kind of program, you convert these annotations and the code into a formula to Z3. And because in this case, you have universal quantifiers, you are actually, instead of being on the bottom of the ladder, you're on the top of the ladder, right? You are in an undecidable fragment and your solver has to use heuristics. And by using heuristics, we have two phenomena that people observe it. For simple problems, it's great. It's fully push-button technology. But when it's not a trivial problem, you get proof instability. It's like by changing the formula, you have A and B, you write B and A, it may affect your ability to prove something. And it led to frustration. The software engineers were really frustrated with this fact. They also were puzzled when something breaks, it's opaque. They cannot understand why something broke in their proof, right? And this led to the creation, to us launching the Lean project, right? Lean, the original mission, and I have data, I try to, because it's more than 10 years, I mean, memory tricks you. I try to use data. Jeremy Avigad helped a lot. Jeremy Avigad has been along with this journey since the beginning. And we had so many mails between us, and he was kind enough to collect mails for this talk, fragments of mails. But how many people here have used Lean before? I mean, okay, I can go really quick here in this one. I think I don't need to explain this part to them. I will skip what's Lean, but the main important thing I think the main message here is to say that you can view Lean, if you haven't used Lean before, you can view it as an interactive game. And Kevin Buzzard would say to me several times that his favorite game, I mean, he loves to play this game. It's really cool to see him doing it in person. But let's go back to the history of Lean. It started 12 years ago. Soonho Kong came to Microsoft for internship. He did not know that he was going to work on Lean. Actually, he came to work on something on SMT. He thought I'm going to work on nonlinear procedures for nonlinear arithmetic because his advisor was interested in analyzing cyber physical systems. And yeah, he was in a completely different world. But we were excited about Lean, and Soonho is a warrior. I mean, he goes for it. I mean, next day he had tons of dependency type theory books in his office. And yeah, we started from the beginning. The goals of the project was software verification, formal mathematics, and domain-specific languages. I'm really grateful for Jeremy for getting old messages. One here he found, this is precise. I keep telling people the name is Lean because we want it to be minimal. And Jeremy found a message from 2013, before we even started coding, when we were just talking about the ideas of creating Lean. And I say that it should be smaller than Z3. Z3 has so many unnecessary optimizations, and the goal is to make it clean. That's why we called it Lean. And our first website was up a few months later in 2014. This is a message that actually was the three of us crafting this message. And contrary to what some people claim, from the beginning, math was there, right? Jeremy has a math background, right? I mean, since the beginning, we had the messages that the goal is to support both mathematical reasoning and reasoning about complex systems, right? And verifying claims about both. Philosophy, right? I mean, Soonho had this point that if your house has a broken window and you don't fix it, it's going to get screwed up over time. And one philosophy we had, we're going to fix any issue as quickly as possible. At the beginning, it worked out. I mean, Jeremy was our first user. His students started using, like Jacob. I don't know if Jacob is here today, but Forrest is watching online. He was also using Lean, and we tried to fix everything as quickly as possible. The kernel was minimal. The goal of being minimal here is that we want to enable others to be able to write checkers, independent checkers for proofs constructed in Lean. We believe that by having multiple checkers, you increase trust. It's very unlikely all checkers, independent checkers, have the same bug. They are probably all buggy, but they have different bugs. If all of them manage to check, there's an extremely high probability your proof is really correct. From the beginning, Lean was supposed to be extensible. And dependency type theory, there's this message from Jeremy. I have a tendency to always do the simplest thing that works. For me, I push a lot during the discussions for high order logic. I thought the design of whole lights was very beautiful, very minimalistic. But the problem is that this kind of logic is too weak. And there's a message from Jeremy saying, you can do abstract math, right, with this kind of system, right? You can prove a beautiful theorem about rings, but you are not going to be able to apply to a concrete structure. A ring is not a first-class citizen in this kind of system, right? So from the beginning, Lean was dependency type theory. And failure was not an option, right? I made the point to Soonho, it's a privilege to work on something you love, right? And it's a privilege. You have to push as hard as possible. If you fail, it's not because it was not by lack of trying, right? So failure is not, if you one day meet Soonho, you have to ask him to impersonate me. He never does in front of me, but I've seen him doing to other people, how I communicate this message to him. Lean 0.1 had dependency type theory, but did not have inductive data types. right? We were constructing the inductive data types for first principles, like it's done in Hall light, Hall, and so on, right? There, basically, you build a natural number. The first thing you build are the natural numbers using the axiom of infinity and Hilbert's epsilon. And if you go back in time in our repo, you're going to find our constructions there. Lean 0.1 was also extensible. But it was Lua, right? You had to use this programming language that is actually very efficient, it's embedded, it's used for many games. And we thought it was a good idea to use a language that was off the shelf, right, to be used. It was a mistake, I will tell you later. But we had extensibility through Lua. And a few months later, this is what we could write. It's not that far from what we have today in Lean. This is a simple theorem proving that the sum of two even numbers is even, right? You have the obtain, we have too many commas here, but the obtain, the syntax is close enough. We use double colon for namespaces. We have the calc. I mean, that's the calculational proofs were there a few months later, but this is there in the repository from January of 2014. But then there's this message that Jeremy found. I'm telling him it's a piece of crap, because we managed to build natural numbers, pairs, lists from first principles. But when you get to dependent pairs, it becomes intractable. Right. We do not have inductive data types in the kernel. And so there is something in Lean called definitional equality, and you do not have the necessary definitional equalities available in your kernel. Independent pairs are crucial for math. I mean, when you're defining a group, right, you're going to have an operator there, and you're going to have a property saying that this operator is associative. This is a dependent, what we call a dependent pair, right? It's a dependent structure. And it was horrible, right, to do that without having inductive data types in the kernel, at least having structures in the kernel. And we had to go back, I mean, rebuild, start again. I mean, we threw away 0.1, and next summer, Soonho was back for another internship, but now we had inductive data types, we had support for recursive equations, Flores and Jacob were power users at this point. We had support for homotope type theory. Homotope type theory was very popular because of Vladimir Voevodsky. He's a Fields medalist. He cares about homotope type theory. We had support for it. And actually, Voevodsky used Lean too. We had it running on a server and a web interface. He used it, and his feedback was, the colors are beautiful. I didn't know he was trolling us, but that was the feedback. The colors are beautiful. I said, okay, great. But he used it. I can claim our first Fields medalist using Lean was Vladimir Voevodsky. Then Jeremy comes to spend 1 month with us at Microsoft Research. We started building a library for Lean. Soonho starts writing an Emacs mode. Again, he has the warrior spirit. He never implements a mode for anything. And he learned how to do it, and we had something that was quite usable at the time. And Ed Clark, his advisor at CMU, he's a Turing Award winner and very influential figure in the automated reasoning community. I also know him for a long time. He unfortunately passed away a few years ago. But he was great, and he said, let's teach a course using Lean. I mean, it was less than 2 years old, the project, right? And we started getting ready for the course, right? In the meantime, we also offered Soonho, Jeremy, Jacob, and Flores were working on the first paper. Our first try was rejected. And the review was super tough, like saying, why do we need another proof of system? That was one of the reviews we got. But we didn't give up. We submitted a system description to CADE. This one was accepted. And a few months later, we were teaching the course at CMU. I think the first win for us is the fact that Tom Hales came to this course, right? To every single lecture. Tom Hales, a famous mathematician, he proved the Kepler conjecture, and he came to every single lecture. And Soonho, Jeremy, and I were creating the content on the fly. I mean, we would teach a lecture, we would immediately start preparing the next one. I mean, and Soonho making sure that everything would work, all the system, and the students were coming. Was a great outcome because Tom got excited about Lean. Then during this course, I forgot about this message. I mean, but Jeremy has this message where he communicates with Sebastian, where in my excitement after that, Sebastian sends a message saying, I'm even more confident that this is the first dependence type theory prover. I could imagine myself switching from Isabel. Right. And we said, wow, it's less than 2 years. We convinced these German students to use Lean. I mean, it was great. And a few weeks later, he sends the first PR to Lean for his first contribution. And this is on GitHub. There is a message from me saying, today I'm crying of happiness because these ideas Soonho had, we have to close the issues as quickly as possible. It's not scalable. As the number of users increases, it's really hard to keep at zero the issues, right? And having someone that's not creating issues, but closing issues, it's super useful, right? Then, the same year, 2015, I meet in the same day Daniel Selson and Mario Carneiro. Both of them had huge impact on Lean's history. It's at the same day, right? And this is the same message I sent to Jeremy, saying that Daniel is from a different world. I mean, if you meet him, you're never going to forget him. He's a unique person. Mario too. In 5 minutes, I knew Mario was really smart. I sent saying, we should get this guy at CMU. I mean, and he went to CMU. I mean, was great. I mean, meeting both of them the same day. And they had it heated, as expected. Both of them have strong opinions. They had a very heated discussion during lunch, but it was great. Okay, it was time to retire Lean too, right? I mean, we had the course, Tom Hales was excited, but Ashan Shipala, he made a really important point. I mean, Lean needs a real static framework. We had hard-coded statics in Lean 2. Well, you could use Lua to implement your own statics, but nobody wants to learn Lua, right? I think I was the only person that wrote any Lua extension in Lean 2. So nobody wants we had a static framework, you could write your statics in Lua, but nobody wants to do that. And another thing that's at the same time, we had another really unfortunate event. I mean, Georges Gontier and I wrote a proposal for getting more resources for the project. It was about Lean and AI for education. I think we had a really strong team. We had researchers from, not just from automated reasoning, proof of systems, programming languages, but also from AI. We had people now that are really famous, like Percy Liang was in the team, right? I mean, from Stanford. But the project was not funded. That was the end of the first era, right? I mean, basically, we got ready to start implementing Lean 3. But before we go to Lean 3, this is an example. Lean 2 is not a joke. I mean, you had in the database Silov's theorem there, right? I mean, you have type classes, you have structures. The proof it's not that alien. You can tell it's Lean. There are more commas. I don't know why we had in Lean 2, we have multiple ways to say the same thing. You could say have, you could say assert. But here you have a bunch of asserts that today we call them haves in Lean 4 and Lean 3 too. But the proof is readable, right? And we have a static framework. Adam doesn't think it's a real one because it's hard-coded, but you could say he writes, you could call the simplifier, was something. Then we start the Lean tree development. I think the main thing here was, okay, nobody likes Lua, nobody wants to learn Lua. Let's allow people to write their extensions, their tactics using Lean itself, right? I wrote an interpreter for Lean, and I actually forgot that Gabriel, I thought Gabriel came earlier to the project, but it was in 2016 that he joined. Jeremy keeps telling him about the new interpreter, that is the code, the interpreter is faster than Python, and and you can write your tactics there, and Gabriel is saying, oh, I'm learning. And Daniel is there at Microsoft with me doing internship. Yeah, it was great. And Jeremy came for another 4 weeks to visit. He would walk me to the bus every single day. We would have really interesting conversations, walking to the bus and waiting the bus to arrive. It was really fun time. I mean, but one sad news, you cannot, sometimes you disappoint your users. We had many users using homotope type theory, but we do not have resources to maintain both versions, the standard and the homotope type theory one. Some people asking me, oh, you have the engineering team at Microsoft. No, there's no engineering team. It was just me there. This is my research project. Microsoft, nobody there knows. I mean, only my manager knows about the project. This is not a Microsoft product. There's nobody. I mean, and building support for the standard Lean for homotope type theory is like building two different systems. You have to implement many tactics twice. They behave differently. We couldn't keep it doing it. Forest maintained the Lean 2 for homotope type theory support until 2018. I see commits from him maintaining the Lean 2 version. And Gabriel put some hacks on Lean 3 that people could play with homotope type theory, but nobody could really build a library because the hacks were unsound. It was more like if you want to play with the technology, you could do it, but it was just a hack. I mean, but then Gabriel, Sebastian, Jared, and I go to Popple to demo our Lean tree with the new metaprogramming that you can write in Lean. I think people were really excited there in Paris. I mean, all 4 of us were there. I think the reception was great. We had a package room. People were impressed. I mean, with the new framework, and we got a paper at ICFP that. And a few months later, we're preparing Big Proof. To be honest, I'm one of the organizers. I'm listed as one of the organizers, but Jeremy and Shankar are the ones that did all the heavy lifting. I think the rest of us were just helping with invitations and so on. This event was crucial for Lean, not because we presented the Lean tree there, right? And people were excited. I mean, some people came to me, actually it was Andre Bauer. He came to me, yeah, you have the engineering team back. I said, no, there's no engineering team. It's just Sebastian, Gabriel, and I. There is no engineering team. That's it. He said, it's just the 3 of you. I said, yes, just the 3 of us. But this is not the most important part. The most important part of that event was Tom Hales presenting the formal abstracts project. Tom was saying we should write papers where the proofs, every claim you make is formal and is machine checked. There's no doubt about what's being claimed on the paper. And he called this project formal abstracts. And in this talk, he says, I'm going to use Lean. After his talk, he was surrounded by people trying to convince him to use some other systems. And in the audience, but remotely, Kevin told me that he was remote. Kevin was there, and he said, if Tom is using Lean, I'm going to use Lean too. And this changes everything. Kevin brought so many people to the community. But at the same time, tensions are rising with the community. It's not this idea of closing issues instantaneously is not scaling. I think the limits, I reached the limits where in this message when I tell Jeremy, that's I'm starting to ignore Kim Morrison. Kim Morrison works with us now at the Lean FRO. And I say I'm ignoring Kim. Kim is creating issues so quickly. I mean, we couldn't, it's impossible to close. It's so many. I mean, and I was telling Jeremy, I have to work full time for Kim. I mean, it's impossible to close everything. And I thought Kim wasn't happy about Lean. Many years later, I learned that from Kim, that Kim was actually super excited about the project, was having a blast. But from my perspective, Kim was hating the project because he was creating so many issues. Another part here is like, it's important. We need, making the point to Jeremy, we need success stories. The project now is 2017. The project is running for 4 years. This in the industry is an eternity. You can keep running a project for 4 years without any success stories. Right? You need impact. You need impact, and we did not have impact. We had a bunch of people working together. The first maybe real thing was formal abstracts from Tom Hales. Doing big proof, Mathlib also we decided to split. Right? I mean, I was maintaining both Mathlib and Lean, the library and the codes were both together in the same repository. I had to maintain both. And I believe, as an open source development model, I believe in the cathedral. But many people in the Mathlib community believe in the bazaar, right? And when you don't believe in the bazaar, but you are the one maintaining the library, is unsustainable. And we had many heated discussions. And we decided to move, to separate. The library and the core system would be living in different repositories. Was that a big proof that this transition happened? And Jeremy said, I don't know if he added this message. I think probably I wrote something much harsher. I do not use the word brats. I mean, maybe for respect to Jeremy, I may have used it. But I would imagine I would do something much harsher. But okay, that's the message Jeremy shared with me. Actually, it's good to check the dates because I thought David visited Microsoft after Big Proof. But actually, David visits Microsoft before Big Proof. And David came, he gave me a copy of his book. And he starts implementing something like code actions for the Emacs modes. But in the process, it was clear we had a limitation. We did not have a way to represent syntax in Lean 3. We had a hack. You would not be able to have a code action that produces a match expression, for example. And this was a big limitation. I created an issue on GitHub that Sebastian claims it triggered the creation of Lean 4. It creates a sequence of events, this issue, that made us decide to build Lean 4. And that was the end of the Lean 3 era, right? I mean, was the 3 guys. I mean, Gabriel, Sebastian, and I writing code. Jeremy was building the library. And after that, I mean, you can see in 2017, Jeremy stops sending to the main repo because he's sending direct to Mathlib. Then the plans for Lean 4 start, right? People are liking this static framework written in Lean. They're writing their own statics. They're pushing it to the limits. So, okay, if people are liking that, let's implement Lean in Lean, everything. Let's implement everything in Lean. Let's enable people to hack, to change things. Sebastian is the only one that says that was up. Everybody was telling us this is crazy. Sebastian just said, "Let's do it." I mean, it's like as inviting him for dinner. Say, "Yeah, let's do it." I mean, it's not a big deal. And he said, even crazier, he decides to do his PhD, right? Only, right? And so we had to say, more important than ever. We could not fail. Sebastian would not graduate if we failed. So now we have to succeed at any cost. And we decided to go private. I mean, I thought it would be easy for mathematicians should understand that. I tried to communicate this several times. They never got it. I tried to explain. Imagine you're writing a paper, working on a proof, and a bunch of people telling you, do this, do that. Why don't you do that? And they do that like they didn't even put 5 minutes to make the suggestion. Zero thought. They're just vomiting things on you. And they expect you to explain why the idea did not work. Imagine you're trying to prove a theorem, and a bunch of people are telling you, do this, do that, and you have to explain each one of them. No, this is not going to work. I don't want to do that. And sometimes it's a personal choice. People never understood that, but I decided to go private. And I have this really short answer when people ask, I want peace, right? So I want to develop Lean in peace. And actually, I had a blast working with Sebastian. I still miss these 2 years that were just the two of us. We would chat at least once a week. I was early morning for me, afternoon for Sebastian. You would keep pushing many ideas, discussing many ideas, pushing the system to the limits. Yes, and I was bitter with the community for all these tensions. And I did not go to the first Lean togethers. I mean, I was so upset. Sebastian went to both of them, representing, giving updates on Lean 4, because it was a private repository. Nobody knew what was going on there. And Sebastian gives updates. And Gabriel maintaining Lean 3 alive. And this is a Herculean effort. And he's telling us, I'm putting band-aids all over the place. I don't know how long I can keep doing that. I mean, the system getting to the limits. Mathlib is getting too big. And then we have a crisis. I mean, Tom Ball, that was my manager, he becomes an IC. IC is an individual contributor. It means that you are not a manager anymore. And here, 2019, 6 years, he's giving cover for the project, right? And he's saying, no, the project should keep going, right? I mean, but he's not the manager anymore. The new manager wants to understand why the hell we spent 6 years building these proof of systems. And Daniel Selson comes up with this idea that's really saved the project. He said, I'm creating, today it feels not a big deal because many groups got a gold medal in the IMO, but at the time, everybody said, this is crazy. Daniel said, I'm launching the IMO Grand Challenge. The goal is to build an AI that will get a gold medal in the IMO. And I'm going to use Lean. The Microsoft director loved the presentation. Daniel joins Microsoft, and later that year, Kevin gives a spectacular talk at Microsoft, explaining why Lean's relevance. These two events gave us at least a few years to keep going, right? And Kevin's making lots of noise. And in 2024, we managed to build, in October, I can't put in words the excitement. It's like reaching the Everest the day we managed to compile Lean 4 using Lean 4. I call Sebastian, I say, Sebastian is super emotionally stable. I never see him panicking, desperate. And I tell him, come on, man, come on. I said, no, inside I'm super excited. I'm not showing you, but I am. It's impossible to explain. I mean, the excitement of this day. I mean, when we managed to compile Lean using Lean itself. Meanwhile, in the meantime, Mathlib is getting a lot of traction. There's an article saying Mathlib is the math library of the future. Lean and Mathlib are selected as one of the breakthroughs in math and science by the Quanta magazine. And the liquid tensor experiments challenge is posed by Peter Schulze, right? He's a Fields medalist. He's working on a new problem. He challenges the community, any proof of system community, to verify his results. Kevin tells me, oh, I don't know. We're going to try anyway. It may take years. We don't know, but we will try. Then we go to present. It feels like it was a lot of preparations, last minute preparations, right? Mark was preparing a VS Code. We did not have, maybe 2 months before the presentation, we did not have a VS Code plugin for Lean 4. Mark was trying to hack something. I was trying to hack simp. We did not have a stable simp yet. Sebastian was fixing the macro system, doing all the preparations for presenting to the public, to all the community Lean 4. This time I went to Lean Together. I had this slide where I was a little bit bitter, where I described the archetypes. But the Coq guys, they love it. The Coq developers, they said that they printed and they put in their office. Because if you go to the Sleep channel, each one of these archetypes, you're going to find them there. Each one of them. Sometimes it's funny. You talk with the person, they find it funny. They don't know they are one of them. I mean, they don't know. That's the funny part. And doing this Lean Together, we were talking to Kevin. He's saying we need success stories. In my mind, at this point, liquid tensor is going to take years, right? But this is also the end of the stealth era, right? I mean, basically, it was mostly Sebastian and I working like crazy to make Lean 4. But then the first major victory arrives. A team led by Johan Komelin manages to prove the main results Peter Schulze wasn't sure about, and did not take years. This was May, a few months later, and the result was on the Nature magazine. Right? Everything started paying attention to Lean at that point. Was huge. I mean, and we're really grateful, Johan. I mean, he's an exceptional person to be able to do this project so quickly, managing a big team. I keep joking with Johan that he's not just a great mathematician, but he's also a great engineer, right? He managed to organize the project in a really, really great way. Then Daniel is starting Mathport. For the IMO Grand Challenge, he's using Lean 4, but Lean 4 is not enough. You need the math library, right? And so he's writing a tool to help porting Mathlib to Lean 4. And he gets Mario to work with him as an intern, right? They start working together. Mario takes over Mathport. He adds a bunch of features to make this insane task of moving more than 1 million lines of code from Mathlib 3 to Mathlib 4. Then a few months later, Daniel and I meet some out. This is true. This is not a joke. OpenAI is using at the time Lean for trying to win the IMO Grand Challenge. And so Altman starts the call saying, I love Lean. You guys are working on small potatoes. We should go after the Riemann hypothesis. I'm not kidding. This is it. This is the... Daniel was super confident, but Daniel was like that. I had to say something. Daniel didn't know what to say. But Sam also makes clear he only cares about AI. He views him, if we create a foundation, he will donate some money, but he will not have a team at OpenAI developing Lean. This is out of question for him. This is not OpenAI's mission, right? But Daniel, his love is AI, and he joins OpenAI like 3 weeks after this meeting. It was tough because he was a good friend. I mean, but in 2022, many, it's great for Lean, right? Meta starts using Lean for trying to solve the IMO Grand Challenge too. The leadership at Microsoft is excited. First time we get headcounts is like you get the right to hire. That's what it means in a big tech company. Headcounts is like you have the right to hire people. And so you get one program manager and two RSGEs. Mac comes for doing internship, for implementing Lake. We have budgets to hire David Christiansen for writing a book about functional programming Lean. The little typer, the book he wrote, his previous book was great. He said, this guy knows how to write books. We hire him to write functional programming Lean. We also have grants to give to the community, small grants. It felt great. I finally make peace with the community in these events at Brown University. Mario, Jeremy, everybody was friends again. And at the time, I also hired Kim and Mario to port the tactics from Mathlib 3 to Mathlib 4. Because we have this math port that can help automating, moving the theorems and the definitions, but the tactics, they're so different, there is no way to port them automatically with tool support. You had to do that manually, and Kim and Mario do that over like 3 or 4 months, take them for doing. And the PM, she was really good. She put them to work and she pressured them a lot and got them on track. And we managed to port the tactics. But in these events, the unthinkable, in my mind, was unthinkable. Johan announces that they finished the liquid tensor experiments, and they not only verified, but simplified the proof without understanding the proof. This was insane. I mean, there's this quote from Peter Schulze. I thought someone wrote for him, but both Kevin and Johan told me that these are Peter Schulze's words. Nobody wrote this for him. I mean, and it was a really happy day to read this message from him. Then come another crisis. I mean, I learned that you have to always expect the worst. And this is true. I mean, things maybe look good, but in August of 2022, the OpenAI leadership demos GPT-4 to the Microsoft leadership. I was completely unaware. I mean, I'm not part of the leadership. But a few months later, the pressure for doing AI increases dramatically, right? And we also have economic downturn. The headcounts are canceled. Gabriel signed it before. He signed the contract in April or May 2022. He's in, but the headcount for Sebastian is gone. Unless he wants to work with AI, something that he refused to do. It was and continues. Mike Friedman is a field medalist that used to work for Microsoft. It's a small world. Mike is also a big friend of Kim Morrison. And he wrote a huge email to the leadership saying, we have to invest in Lean. This is the future. This is super important. He wrote a beautiful email. We did not even receive a reply. I mean, and it was clear that it was time to go. I mean, unless we want to work on AI, we could be there working on AI. It was not clear if we could keep pushing the project. Sebastian and I were working on the proposal for the Lean FRO. Now feels so easy, but at the time we just know who these people are that were trying to raise the money for us. We just know how it would work. If we were liable for the money, we just know the details. We were learning everything on the fly. It wasn't clear. And Jeremy, people did not know if Mathlib would be ported or not. Many doubts, many people telling us, oh, it's going to be like Python 2 and Python 3. I mean, Lean is going to be forked system. You'll never succeed. What stuff? I mean, Mike and I leave Microsoft the same day, and I go to AWS. But at AWS, Soonho is there. I mean, and Soonho starts a massive campaign to promote Lean at AWS. We have our first customer, Emina Torlak. She loves Lean. It's easy to get people that are excited about the technology. And he comes up with many things. I think the funniest is I don't have any social media, but now I post on LinkedIn was Soonho's idea. We have to create LinkedIn accounts, and we force Sebastian. Force like say, Sebastian, have you created your LinkedIn account? Sebastian, have you created? And Sebastian, now he posts on LinkedIn. It's amazing, but he does it. Then we have one of the first posts is about the Mathlib port. A few days before the FRO was launched, the impossible happened. The community managed to port more than 1 million lines from Mathlib 3 to Mathlib 4. And they do it at the exact 10-year anniversary of the project. It's by accident, but it was exactly 10. It feels like it was planned, but it was not. And Patrick records a video where he demos Lean FRO to the whole community. He doesn't know how happy I was with his video, but I'm really grateful for him. I mean, it's a really beautiful video. And a few days later, we have an article at the New York Times where they mention Lean. This is the end of the FRO, pre-FRO era. We have now funding for 5-year mission. We're super grateful for the resources, the philanthropic donations we got. And Sebastian and I, we are running the FRO as a startup. This is a privilege, an opportunity we cannot miss, right? And everybody was skeptical if you're going to be able to hire people, but we got very quickly, Kim, David, Mac, Mark, Kyle, they all joined the FRO. Him also joins the FRO. Our roadmap is public. And from now on, it's a tsunami of success stories. I mean, you probably know many of them, like Terry Tao starts using Lean, finding a bug in his paper. A few months later, he formalizes one of his results in record time using Lean. Harmonic, Daniel again. Daniel connects me to Tudor and Vlad, and I meet them in the Bay Area, and they tell the plans for Harmonic. Again, connect to the Emogram Challenge. They say, we want to get the gold medal, right? Emina managed to do her project using Lean. Is a huge success. She shows dramatic productivity gains. It's much maintenance now is reduced to, instead of weeks, is hours. Whenever it has to update the system, it's faster. She keeps telling the whole at AWS. She goes around telling Lean is the way, right? It was SAMSURT is another great project that uses Mathlib. I mean, I think the Mathlib community thought there was no use for math. But there is. I mean, cryptography, facial privacy needs math. And people were really surprised with this project that Jean-Baptiste Tristan did using Lean. And then Alpha Proof shows up in the summer of 2024. Yeah, nobody expected this. In 2024, we would have an AI that would reach a silver medal level status. This quote from Pushmit Kohli summarizes, and Pushmit, when I met him later that year, tells me Daniel again was the one that put in his mind the idea that IMO was a worthwhile challenge. A few months later, we are again in the New York Times because of Harmonic. Microsoft is using Lean now for cryptography and Mathlib. And one of the cryptographers tell me that he's blown away by Mathlib, has all the right abstractions. He cannot imagine using any other system. And Terry Tao now is on YouTube. You find many videos of him talk about Lean AI. You can see him using Lean online, him on podcasts like the Lex Friedman podcasts. We have projects like the Carlson theorem that was just completed by Flores. Fermat's last theorem but is still going with Kevin Buzzard. We have many gold medals this year, 2 of them using Lean, startups using Lean, vibe coding using Lean. People are proving theorems now, vibe coding, but it's now vibe proving because you have a certificate. You have absolute assurance that your result is correct. And the startups are all using Lean, are proving open conjectures that have been open for more than 2 decades. And it's not just math. We are seeing also impacts in computer science, right? Harmonic just crushed the Verena benchmarks for verifiable code synthesis. The Mathlib initiative has been launched, right? Before Mathlib initiative, the Lean FRO was helping to maintain Mathlib. Now we have an organization dedicated to that. And the Lean FRO by numbers, right? So you have more than 25 releases, more than 7,000 pull requests. The FRO now has 15 people, and the roadmap is public. The whole team, I try to capture, we cannot hire more people, otherwise it's not going to fit on these slides. The only people missing is Emilio that started last week. But we are all grateful by everybody that joined the FRO. Yeah, I think for me it's hard to say anything. I will just keep for a few seconds these slides. I mean, I would just say that my kids joke that I like Sebastian Ullrich more than I like them. Yeah. I mentioned in the abstract that I would give you a demo of Grind, but I realized that would not be feasible. But Yanis is organizing a project where to put annotations on Grind and Aesop to teach people to use these tools. I will be there. The only thing I want to say that Kim and I are working on Grind. And one thing that's made me really happy that we finally Kim came to the Lean community because Kim was really unhappy with a paper they published where they were using a computer algebra system. And for mathematicians, it's like blasphemy, but now we have a verified proof for one of the results in their paper. Thank you very much for your attention. I hope you get more excited about Lean. You use the system. All this you can get the slides online using this QBR code. Visit our website. Thank you very much for your attention.
Thank you. That was very exciting. Thank you very much for sharing this story. We have time for maybe 1 or 2 quick questions from the audience.
Hi, thanks. Great talk. I was curious, you mentioned back in Lean 2, removing the hot support. It's kind of interesting because now there's a resurgence in this there's the work and the new proof assistant that John Sterling is working on, and then there's Mario working on embedding hot, this hot Lean system. So I was just curious what you think about this idea that seems to come up a couple of times of embedding these different proof modes in Lean.
Well, I view as follows. I mean, I'm not a mathematician. I can only share what mathematicians like Kevin Buzzard have shared with me. Kevin Buzzard views like you are moving the problem. I mean, you're going to make, for going to homotype theory, a prover based on homotype type theory, you're going to make some things easier, some things more complicated. For software verification, I can tell you for absolute confidence, you are just going to make things more complicated. I mean, I don't see any, nothing will become easier. We have limited resources. You have to use the resources you have the best way we can. Today, when people approach, we are going to support this, I think our philosophy is, if we see, we are providing a foundation for people to build on top of. Right? Lean will only be successful, you have successful users. If we see a user that has a real project that will change mathematics or software development, we will support it. But otherwise, we have There are millions of things people want us to develop in Lean, millions of things that need to be improved. We have to picking the right problems to work next. It's super important, right? The ones that have the most impact. We do not take for granted. We're still fighting for I think the way to summarize the story of Lean is the story of keeping alive what you love and picking the right problems to work on, pushing super hard is super important. If someone shows me that I have this big project that will have tremendous impact, but we need homotope type theory, I think it would be worthwhile for the Lean FRO to invest there. Otherwise, we have to support projects like there are people doing last team like Kevin Buzzard. Mochizuki wants to do the ABC conjecture in Lean, right? There's people trying to do hardware verification, software verification, projects that will have a huge impact. We have to prioritize these projects, right? Because we see the impacts they will have.
Yeah, thank you. And just to be clear, I think it's kind of a testament to Lean that the fact that, even without core support of HOT or anything like that, the fact that Lean is so extensible to go write another proof assistant in Lean, this is amazing. It wasn't meant as a criticism in any way. So, thank you.
One more quick question from anyone?
Hi, thank you very much for the beautiful talk. I was wondering if you can tell something about the history of introducing mutually inductive types. Who had the idea, when, why? So something about the history of this idea.
In Lean 2, we had the mutual inductive types, but in Lean 3, we felt like, we can simulate them. We can compile them in non-mutual inductive ones. And actually, guess who did it? It was Daniel. Daniel implemented the compilation from mutual inductives to regular inductive data types. The problem is that you lose some definitional equalities in the process, and also the compilation leaks to the user, and the user gets really confused when it's exposed to extra compilation steps. In Lean 4, we put it back. But the idea is the implementation in Lean 4 is based on a paper from, I don't know how to pronounce his name, Dieber. He wrote like inductive family. He has a really super detailed paper about mutually inductive families. The Lean 4 the Lean 2 and Lean 4 are based on his paper.